Teaching hydraulics through English Click Approach. Preface. This manual deals with the basics of hydraulic technology, describing types and design features of oil fluid treatment equipment, also known as hydraulic devices, actuators, valves, the interconnection between them, and introduces the idea of hydraulic circuits. The correct use of hydraulic devices requires good knowledge about safety, order laws of physics, and symbology to ensure the integration of logic devices into an effective working system. A fluid power system is one that transfers and controls energy using pressurized liquid or gas. In industrial hydraulics, the medium is oil. The press machine is a good example, and others will be seen later. Hydraulics is one of the basic technologies used in modern industries. For this reason, it's part of the syllabus of vocational technical schools in Mexico. Introduction. What is CLIL? CLIL, Content and Language Integrated Learning, is an approach that integrates the teaching of curriculum content through a non-native language. It is increasingly important in our global technological society where knowledge of a second language helps students to develop skills in the mother tongue as to communicate their ideas to people around the world. CLIL presents new challenges for both teachers and students by providing a different learning experience where there is a fusion between subject content, thinking skills, and a new language. Who is this manual written for? It is intended for specialist teachers in technical areas. This manual is a tool that allows teachers to direct the training process related to hydraulic system using an epistemological approach, which allows students to develop and execute activities of the industrial area. What are the contents of this manual? This manual has 5 parts totaling 40 teaching hours to analyze and develop the established activities. Focus on a theoretical concept in order to promote practical activities. The first part is about maintenance. The second part corresponds to a fundamentals of hydraulics. The third part consists of modern hydraulic applications. The fourth part deals with hydraulic components, and the fifth with hydraulic circuits. At the end of each part, it is recommended to carry out feedback and consolidation of the acquired learning and/or to answer questions about the contents or process studied, allowing teachers to evaluate the closure of the diagnostic, formative, and summative evaluation procedure. The foregoing is not just another evaluation system. It can be used to integrate the evaluation criteria and contents. Closing notes. Teachers assigned to lecture about technical subjects are very important in directing the learning process, including both explanation and development of contents and acting as guides and facilitators in order to strengthen the students' technical professional training and professional generic and disciplinary skills. The contribution of this manual to the graduate profile of students with technical professional training strengthens the knowledge and skill in the 4th and 5th semester of the professional technical career, depending on the institution or subsystem. In the maintenance of hydraulic system coupled to industrial processes using standardized techniques, equipment, and tools, in addition to depending the study of hydraulics. Therefore, it is expected that this manual serves as foundation of other future projects and research that provides feedback and improve the processes in this area of knowledge, since it is a technological, pedagogical, and bilingual field. Part 1. Maintenance. Learning objective. Students will be able to know, identify, and distinguish the main types of maintenance in hydraulic systems. Duration: 5 teaching hours. Description of contents by topics and subtopics. 1.1 Main types of maintenance. 1.2 Corrective maintenance. 1.3 Preventative maintenance. 1.4 Total Productive Maintenance, TMP. 1.5 Activities. Assessment criteria and procedure. Diagnostic evaluation. The diagnostic evaluation will take place at the beginning of the model and will serve to measure the degree of skills and abilities that students have. Formative assessment. Exam, written, oral presentation of projects, etc. 40%. Continuous evaluation, exercises, activity, tasks, and project presentations 60%. Summative assessment consists of the sum of the exam and continuous assessment. Description and development of the contents. 1.1 Main types of maintenance. Maintenance in general can be defined as efforts taken to always keep the conditions and performance of a machine similar to those the machine had when it was brand new. Maintenance activities can be basically divided in two parts: planned maintenance activities and unplanned maintenance activities. Planned maintenance is maintenance that is organized and carried out with planning for the future, control and recording in accordance with the plans that have been determined previously. The type of maintenance cannot be the same for all the machines. It depends on the method, cost, and critical level of each part of equipment. The following types or maintenance methods are commonly used in several industries and require teamwork. Corrective maintenance. Corrective maintenance is inherently part of emergency maintenance because when there is an emergency, something needs to be corrected or fixed. In this way, corrective maintenance is mostly reactive. Corrective maintenance, also called breakdown maintenance, involves maintenance tasks that are performed in order to rectify and repair faulty systems and equipment. The purpose of corrective maintenance is to restore broken down systems. If corrective maintenance is not scheduled, the problem may become an emergency maintenance work ordered down the road and result in halted production lines, interruption in service, or unhappy customers. 1.3 Preventative maintenance. Preventative maintenance is extremely important for making sure equipment always runs as smoothly as possible. If it is a car, maintenance will be avoid failures so that it does not get stranded off the side of the road. Some facilities may see the cost of preventive maintenance program as excessive, but thinking like this is a bit short-sighted. The amount of resources a good preventive maintenance program can save on equipment downtime, emergency maintenance work, and lost profit due to the failure assist more than outweighs that initial investment of implementation. Preventive maintenance before a failure has occurred versus corrective maintenance after a failure has occurred. There are more benefits of implementing a preventive maintenance program than merely reducing the amount of unplanned downtime. Other benefits include extension of a system lifetime, increased safety and reduced risks of injury, optimized maintenance planning and resource allocation, less expensive corrective repairs, better margins and profits due to less downtime. Perhaps the greatest benefit is increased safety, especially for a company that owns heavy machinery. The price of employees' safety is never too high. An organization such as Occupational Safety and Health Administration, OSHA, in the United States Department of Labor rigorously enforces government policy. It is often said that preventive maintenance reduces expenses for unplanned downtime, but it is true that preventive maintenance can improve safety as well. How? It all comes down to the fact that when heavy equipment stands wearing out, it can be dangerous. To really understand the impact preventive maintenance has on workplace safety, it might help to look at a few examples. Detecting equipment failure. Equipment failures can result for something as simple as a worn belt or damaged roller. Depending on the situation, even a mirror issue can become dangerous. For example, steel cables are widely dangerous and they can result from damaged rollers. A failure cut-out valve on a boiler could result in massive injuries for those nearby. Preventing hazardous situations, some of the risks posed by poorly maintained equipment are less dramatic but still significant. For example, a poorly maintained ventilation system could lead to dangerous gas buildup. HVAC, heating, ventilation, and air conditioning maintenance is key for most plants that require regular preventive maintenance. Another example would be leaks or condensation leading to a poorer water. These issues often result from poorly maintained assets, such as condensation from a multifunctioning freezer. Again, regular inspection would head up this problem. 1.4 Total Productive Maintenance. Total Productive Maintenance, TPM, is the broadest type of maintenance that targets more than the need of maintenance. It also aims to provide employee satisfaction and overall morale in the workplace, especially in manufacturing plants. TPM does this by increasing overall equipment effectiveness, OEE, and the amount of planned maintenance. More planned work means more workers have the resources they need to do their job, which means higher levels of satisfaction. TPM also leverages machine operators to participate in a maintenance and take ownership of their equipment. Get started with total productive maintenance today. 8 pillars of TPM. Autonomous maintenance, focused improvement, planned maintenance, quality management, early equipment management, education and training, administrative and office, safety, health, and environmental conditions. Autonomous maintenance, routine maintenance, such as cleaning, lubrication, and inspection, is performed by the machine operator. Focus improvement, creating a voluntary small group to identify the cause of failure, as well as possible plant and equipment modification. Planned maintenance, data-driven maintenance schedule using prediction and failure rates. Quality management, creating production processes to detect and prevent errors. Early equipment management, designing new equipment based on knowledge and understanding gained through TPM program. Education and training, train and educate operators, maintenance and managers know necessary information to achieve TPM goals. Administrative and office, seek ways to apply TPM to administrative and office functions. Safety, health, and environment conditions, ongoing maintenance of a safe and healthy workplace. And remember to always wear PPE. Part 2. Basics of hydraulics. Learning outcome. Students will be able to know, identify, and understand the basic concepts and components of hydraulics, Pascal's Law, and Joseph Bramah's hydraulic press. Duration 5 teaching hours. Description of contents by topics and subtopics. 1.1 What is hydraulics? 2.2 Pascal's Law. 2.3 Joseph Bramah's hydraulic press. 2.4 Modern hydraulic press machines. 2.5 Hydraulic press machine components. 2.6 Types of hydraulics fluids. 2.7 Viscosity. 2.8 Activities. Assessment criteria and procedure. Diagnostic evaluation. The diagnostic evaluation will take place at the beginning of the model and will serve to measure the degree of skills and abilities that students have. Formative assessment. Exam, written, oral presentation of projects, etc. 40%. Continuous evaluation, exercises, activity, tasks, and project presentations, 60%. Summative assessment consists of the sum of the exam and continuous assessment. Description and development of the contents. 2.1. What is hydraulics? Hydraulics is the science of forces and movements transmitted by means of liquids. At its most basic level, hydraulics is the generation, control, and transmission of power using pressurized liquids. The word hydraulics generally refers to power produced by moving liquids. Hydraulic circuit is a system to supply energy by means of a liquid under pressure. Although hydraulic power in the form of water wheels and other simple devices had been in use for centuries, the principles of hydraulics weren't formulated into specific law until the 17th century. It was that French philosopher Blaise Pascal discovered that liquids cannot be compressed. Physical states: increasing energy. Solid. The molecules that make up solid are arranged in a regular, repeating patterns. They are held firmly in a place but can vibrate within a limited area. Liquid. The molecules that make up a liquid flow easily around one another. They are kept from flying apart by attractive forces between them. Liquids assume the shape of their containers. Gas. The molecules that make up a gas fly in all directions at great speeds. They are all so far apart that attractive forces between them are insignificant. It is necessary to understand that hydraulics and pneumatics are different technologies because solids and liquids cannot be compressed and gases can be compressed. 2.2. Pascal's law. Pascal discovered a law which states pressure applied on a confined fluid is transmitted in all directions with equal force on equal areas. To better understand Pascal's law, let's think of a bottle full of liquid as an example. Let's say the bottle has a 1 square inch opening. 10 pounds of force were applied on a cork at the opening. 10 pounds of force would be applied equally to all sides of the bottle. This is expressed as 10 pascals or 10 pounds of force per square inch. 10 pascals represents the fluid pressure of the system. Pascal's law states the pressure applied to a fluid enclosed container is transmitted equally to all points in the fluid and act in all directions of the container. Pascal's law is applicable to both solids and liquids. He observed that when a fluid is at rest, the same amount of pressure is applied at all the points which are the same height. Pressure is not a vector quantity, and therefore it cannot be assigned any direction. Consider that fluid is an horizontal bar with an uniform cross-section and it is in a state of equilibrium. Then there will be an equal and balanced force which will be extended at both ends. However, if an unequal force is acting on an horizontal bar, in that case, the liquid will have some net force acting on it and it will flow. Therefore, it can correctly be said that since the liquid does not flow, it has equal pressure acting on it at all the points. 1 Pascal equals to 1 Pascal equals to 1 Newton per square meters equals 10 to minus 5 bar. Two 2.3. Joseph Bramah's hydraulic press. Pascal's law wasn't put into a practical application until the Industrial Revolution when Joseph Bramah, a British mechanic, build an hydraulic press using pressure, force, and confined fluid in a lever-like system. A closed hydraulic system, such as the one diagrammed here, provides a mechanical advantage like that of a simple lever. Pressure is equal to the force divided by the area on which it acts. According to Pascal's principle, in hydraulic system, a pressure extend on a piston produces an equal increase in a pressure on another piston in the system. If the second piston has an area 10 times longer than the first, the force on the second piston is 10 times greater, though the pressure is the same as the applied on the first piston. The effect is exemplified by the hydraulic press based on Pascal's principle, which uses in such an application as hydraulic breakers. Pascal also discovered that the pressure at the point is a fluid that rests in the same in all directions. The pressure would be the same on all planes, passing through a specific point. This fact, also known as Pascal's principle or Pascal's law. Consequently, Bramah discovered that in a closed fluid system, a small force extended on a small cylinder could balance a large force on a large cylinder. For example, 1 pound of force applied to a 1 square inch cylinder can balance 100 pounds of force on a 100 square inch cylinder. This is how a 100-pound weight can be moved by using only 1 pound of force. The distance that 100 pounds will travel is inversely proportional to the distance that the applied force travels. That means if a 1 square inch cylinder is moved 1 inch, the 100 square inch cylinder is only moved 1/100th of an inch. A small force can move a longer weight if the small force is moved through a greater distance than a large weight. 2.4 Modern hydraulic press machines. Hydraulic press are commonly used for forging, clinching, molding, blanking, punching, deep drawing, and metal forming operations. The hydraulic press is advantageous in a manufacturing. It provides the ability to create more intricate shapes and can be economical with materials. Hydraulic press will take up less space compared to a mechanical press of the same capability. Modern hydraulic press machine. 2.5 Hydraulic press machine components. First, hydraulic fluid is forced into a small double-acting cylinder by a hydraulic pump or a lever. There, the fluid encounters a sliding piston, which tries to compress the fluid It instead shows the fluid through the small cylinder into a larger cylinder, where the process is repeated. This time, the compressive force forces the fluid back into a smaller cylinder. The fluid is passed back and forth between cylinders, causing pressure to build. Eventually, the pressure becomes too great that it reaches the anvil, base plate, or die, deforming the material beneath into the desired product shape. To make sure that the press does not overload the material, when it matches its pressure the threshold, the fluid activates a valve that activates pressure reversal. Motor, oil tank, pressing plate, valve compartment, hydraulic cylinder, pressure gauge, relief valve, electrical control box, manual control valve, limit switch, safety door. Hydraulic press has all the essential components of a basic hydraulic system. It has a set of cylinders, punches or pistons, hydraulic pipes that move the fluid, and die, or anvil. The pistons use liquid under pressure to push on the anvil with a high level of force. The hydraulic fluid is the force into the cylinder when the pump is activated. There are two cylinders, and the fluid oil is deposited into the smaller of the two. When the small piston is pushed, it compresses the fluid. This compressed fluid then flows through the pipe to the master cylinder. This pressure on the large master cylinder and its piston causes the flow to be directed back to the small cylinder. At this point, the force on the fluid in the smaller cylinder creates even more force when it is pushed back into the master cylinder. It is extremely high force that brings the punch in the contact with the die and accomplishes whatever press operation is being performed. There are many different types of hydraulic presses, and each one is used for its own set of applications. The main types of hydraulic presses are C-frame press. A C-frame hydraulic press is used for metal forming, straining, blanking, punching, drawing, and riveting operation which require force and position. Because of their narrow shape, C-frame presses take up less floor space than many other models, making them convenient for small to mini-sized facilities. C-frame presses can be manually or automatically operated. H-frame press, used for tasks or applications that require coning, crimping, bending, punching, and trimming. The welded frame of an H-frame press makes it capable of performing many different operations. Laminating press. A laminating press makes it possible to apply film to many different materials or create encapsulating layers for electronic components. These presses are operated manually and compression takes place between plates, one for heating and one for cooling. Stamping press. Like a laminating presses, stamping presses are specialized machines used to shape or cut materials using deformation with a die. Stamping presses or stamp presses are very common in the automotive and metalworking industries. Transfer press. A transfer press stamps and molds material like plastic, rubber, and metal. Flat plastic can be filled automatically into the end of the press where it is pulled from one die to the next by feed bar fingers. Vacuum press. Vacuum presses are hydraulic presses specialized to seal materials and products using atmospheric pressure. Vacuum presses are used to apply film to a wide variety of materials. Also, they're used to encapsulate items like ID cards and credit cards in plastic layers. Platen press. Broadly speaking, platen presses features a ram and soiled stable working surface. Forging press. Forging presses, also known as hydraulic forge presses, are used to shape metal only. They are used to shape vehicle parts. They use either another or closed mold, pressure force, and sometimes heat. They force metal blocks into shapes. During forge pressing, the metal stitches beyond its yield point but does not crack or break. Hydraulic press brake. Hydraulic press brakes are typically constructed from two C-frames on the sides, a movable beam on top, and tool mounted at table below. Unlike non-hydraulic press brakes, this press brake features two synchronized hydraulic cylinders on the frame, which moves the beam. If automated, this press is called a CNC press brake. Manufacturers use hydraulic press brake to fold, bend, and otherwise cut work sheet metal. Shop press. A shop press or hydraulic shop press can repair, remove, and set small parts like bearings, U-joints, and bushings. It can also strengthen the bent parts. Shop presses work very well for automotive repair, especially in small garage businesses. 2.6 Types of hydraulic fluids. Hydraulic fluids used in hydraulic installations must fulfill different kinds of tasks: pressure transfer, lubrication and the moving parts of devices, cooling, cushioning of oscillation caused by pressure jerks, corrosion protection, signal transmission. There are various types of fluid with different characteristics that are determined by a basic fluid and small quantities of additives. Hydraulic oil HL, hydraulic oil HLP, hydraulic oil HB. The designations for those oils are compressed on the letter H for hydraulic oil and an additional letter for the additives. The code letter is supplemented by viscosity code. Designation HL. Special characteristics: increased corrosion, protection, and engine stability. Areas of application: systems in which high thermal demands are made for corrosion through immersion in water is possible. HLP. Special characteristics: increased wearing protection. Areas of application: like a HL oil, also used in the systems where variable high friction occurs owing to design or opening factors. HV. Special characteristics: improved viscosity temperature characteristics. Areas of application: like HLP oil, for using at widely fluctuating and low ambient temperatures. HLP 68. H. Hydraulic oil. L. With additives to increase corrosion protection and or engine stability. P. With additives to reduce and or increase load carrying ability. 68. Viscosity code. Where these hydraulic fluids are concerned, a distinction is made between hydrous and anhydrous synthetic hydraulic fluids. The synthetic hydraulic fluids are chemically compounds, so the vapor is not flammable. Abbreviated code: HFA. Composition: oil, water, emulsions. Water content in percent: 80, 98. HFP. Composition: water and oil emulsions. Water content in percent: 40. HFC. Hydro solutions, example water, glycol. Water content in percent: 35, 55. HFD. Anhydrous liquid, example phosphate ether. Water content in percent: 0, 0, 1. For hydraulic oils to be able to fulfill the requirement listed above, they must exhibit certain quantities on the relevant opening conditions. Some of these quantities are listed here. Lowest possible density, minimal compressibility, viscosity not too low, lubricating film, good viscosity temperature characteristics, good viscosity pressure characteristics, low flammability. 2.7 Viscosity. The word viscosity can be defined as a resistance of flowing. The viscosity of a liquid indicates external friction, the resistance which must be overcome to move two adjacent layers of a liquid against each another. Thus, viscosity is a measure of how easily a liquid can be poured. The most important distinguishing features of hydraulics is viscosity. A center point is 1 millipascal second, MPa(s). In SI units, 1 centipoise equal to 10 2 pascals equals 10 3 pascals. Centipoise is properly abbreviated CP, but the alternative abbreviations CPS and CPS are also commonly seen. Water has viscosity of 0.0089 poises at 25 centigrades or 1 centipoise at 21 centigrades. Described as a unit of dynamic viscosity, center poise is an amount of force necessary to move a layer of liquid in a relation to another liquid. Center point is considered the standard unit of measurement for fluids of all types. It is 1/100th of a poise. The symbol for center point is Cp or Cps depending on the source. A ball viscometer can also be used to determine kinematic viscosity. It can be used to measure viscosity values presently across a board area. Measurements are made to determine the speed with which a body sinks in a liquid under the influence of gravity. To find the kinematic viscosity, it is necessary to divide the value determined using the ball viscometer by the density of the fluid. One important method of identifying hydraulic oils is the specification of viscosity class using the ISO standard. 6 different viscosity classes are available for the various types of hydraulic oil: HL, HLP, and HB. The table below specifies areas of application for the different viscosity classes. It is necessary here to match the viscosity class to the ambient temperatures. For storage reasons, high-grade motor or gear lubricating oil is also used in hydraulic installations. For this reason, the CAE viscosity classification is also listed here. However, this classification allows longer tolerance zones, as can be seen from a comparison between two methods or classification. When using hydraulic fluids, it is important to consider their viscosity, temperature, characteristics, since the viscosity of hydraulic fluid changes with changes in temperature. Mineral oils with a high viscosity index are also referred to as multigrade oils. They can be used anywhere where very changeable operating temperatures arise, such as mobile hydraulics, for example. Where oils with a low viscosity index are concerned, a distinction must be made between summer oils and winter oils. Summer oils have higher viscosity so that the oil does not become too fluid, causing the lubrication film to break up. Winter oils have lower viscosity so that the oil does not become too thick and a cold start is possible. The viscosity pressure characteristics of hydraulic oils are also important, since the viscosity of hydraulic oils increases with increasing pressure.